All right. So I'm going to look at the purple. 4, 5, 6, 7, 8, 9, 10 are the two where I am's did. Now you gotta disagree or not disagree, but those are the ones you'll look at because people didn't understand the question I was asking. So look at those answers. Disagree if you can. Or not disagree, but you know if there's no disagreement, then go else you're gonna do.
Number 8 is in quadrant 3.
Oh.
Number what? 8.
And the assessment I'm giving you on Wednesday won't need you to know this stuff. You won't need to tell me if this thing is on Earth. If not, what are you going to do to bring it down to Earth? Once you do that, what quadrant that will be in? What will be the sign of the cosine and sine values in those quadrants? What will be the reference angle? And then what will be the exact values of them? You won't need to do those. Anybody disagree or anything with that board? Please make sure you step up now. Going once. Except for number 4, anything else? Going twice.
4. I would switch the cosine.
Okay, let's look at number 4. Number 4 is asking you to find the cosine and sine of 2,115 degrees. So what that means is how many rotations we have to get this off first. So the first question is, and then the second question is if it is quadrant, and the third question is reference angles, and then the last one is just the values. Okay? So 2,115 degrees, is that on Earth?
No.
No. Why not?
Because it's above 360.
Because it's more than 360. To be on Earth, you got to be in a circle. Earth is still circular. Regardless of what other people say, we still live on a round planet. Okay? So it has to be between 0 to 360 degrees to be on Earth. It's not. So now we got to take a lot of those rotations out until we bring you down here. Because right now you acting like you're up there. You acting like you're all bougie. I'm going to bring you down a little bit. Right? I got to adjust your status a little bit. So you got to pull a little bit of some weight, right? Bring some people down. So that's what you need to do. So if I got 2,115 degrees, how many 360s can I take out of there?
6.
Take out 6?
Yes.
And what, well, how much are they going to do?
2,160. What number?
Number 4.
Yeah, take out 6 rotations. You can't. Oh. 5.
You got to take out 5 rotations. Right? If I take out 5 rotations, I get left with 30 degrees, right? Is that it? No, 45 degrees.
Yeah.
So I'm doing 5 times 360 plus 45 degrees. That's what that thing is equals to. It takes us back to the opening problem where we're asking questions about people putting money together in an office and saying if they win, they divide the money evenly amongst themselves, 360 of them, and then whatever is left over gets sent to the local school district. So it's the same thing here. Is the question might be, what happens if they win $2,115? Well, now they each get $5 because that's a rotation of 360s, and then $45 get left over. Just taking us back to the opening problem. You see that? So now, when we bring that to Earth, it will be 45 degrees. When we interpret it, it will be 45 degrees, right? 2,115 degrees is like alien speak, right? It's like they're out there somewhere, we took a spaceship there and they're speaking to us in their language. We got to interpret that for what it looks like on Earth. On Earth, that would be 45 degrees. What quadrant would that be?
1.
Quadrant 1. Now, in quadrant 1, what is the sign of the cosine value?
Square root of 2.
No, not the exact value, the sign, plus or minus.
Plus.
Plus, and the sign?
Plus.
All right, because in quadrant 1, they are positive. What would be the reference angle?
45.
Why?
Because it is itself, because it is within the 90.
Yeah, it is itself. The reference angle is going to be itself because the reference angle is still in the first quadrant. Because we always need our reference angles to be in quadrant 1. Because where I am, she get it now?
Yeah.
Yeah. Reference angles always have to measure between 0 to 90 degrees in quadrant 1 where everything is positive, right? Cosine is positive, sine is positive, tangent is positive. When nothing else has happened yet to change anything, right? We stay in our natural habitat, right? Positive. So now, what is the cosine of 45 degrees? Square root of 2 over 2, and the sine is also square root of 2 over 2. And if you don't know where those are coming from, book of Numbers, page 26. You have a nice little art on that page. We're good? Anybody with a question? All right, then let's extend this knowledge. Let's flip the page to today's work.
Mr. I have a question.
Yes,
Never mind.
I didn't mind. All right, so,
Wait, no.
what's your question?
For the negative ones, how do you determine which of the numbers is going to be negative?
And which one? The which is simple. Because I don't know what you mean by which number is going to be negative.
Like, which is the sign of the cosine of both of them? Because it was different, wasn't it?
Which problem we're talking about? If I give you a negative angle, is that what you mean?
No,
Like which one is the negative equivalent?
the sign of
How do we determine which of the sine or cosine is going to be negative? Is that a question?
I can't
Well, here's the thing. If I'm understanding you well, the way we determine which of the values are going to be negative with a sine or cosine is based on the quadrant, right? Because in quadrant 1 they're both positive. In quadrant 2 the cosine is negative, the sine is positive. So if the angle came from quadrant 2, then the cosine is going to be negative. In quadrant 3 they're both negative. In quadrant 4, the angle measurements in quadrant 4, then the cosine is positive and the sine has to be negative. So was that a question? But if we're dealing with a negative angle, then the first thing we need to do is to find out what the positive representation of that will be. Then we look at what quadrant that will be. So we're not magically guessing. Okay? So let's look at what are one of those negative angles. We did, say for example, negative 30. Remember we did negative 30 degrees? And we said negative sign just depending on which way we went, whether clockwise or counterclockwise. And if we went negative, we got down in the fourth quadrant. So we knew cosine had to be positive and sine had to be negative because it's the fourth quadrant. And that gives us 330 degrees. Right? And if you actually think about it, when you start dealing with negative angles, so when we drew that circle on the board, let me go back to remember the time. We said if we started here, and we went back to do negative 30 degrees, it just means I should move here 30. So that means this is where I want to be. All right? I want to go down here 30. So that means, what is this space equals to now? 60 degrees, right? Because this entire quadrant is 90 degrees, right? So remember the conversation about putting an address in your GPS. And this GPS said, well, here's going to be the shortest route. So it takes you from here, here. You start at here, and you end at here. Versus another GPS, I go, you know what? there is a lot of traffic on this route. So I'm going to give you the best route with less traffic. So it's going to let you travel this way. From here, you get here, that's in the positive direction of 90 degrees. And then you get here, that's in the positive direction of another 90 degrees. And then it brings you here, still in the positive direction of 90 degrees. And then it has to bring you here. Now this is plus 60, right? So we had 90 plus 90 plus 90 plus 60. That's a 330 degrees. Right? So the equivalent representation in positive of a negative 30 degree is positive 330 degrees. Now if you pay attention to this purple thingy along with this red thingy, what do they form together? A circle, a 360. So technically, if I consider the absolute value of the negative sign, if I'm not worried about which way I'm traveling, this way or that way, then all I need to do in order to find the representation of that thing is to take it from 360. Because all we have done is to say 360 degrees minus the absolute value of that thing. So minus 30, which would be what? 330 degrees. Okay? Because when you start having big numbers in negative, you gotta know that if I come this way and complete the circle, it's still 0. Doesn't matter which way I went, positive 360 or negative 360, it's still full rotation. It's just giving me directions on which way I get my rotations. And I can throw that out. We're good? So today's work starts with case number 1 on page 32. Case number 1 on page 32. The bottom of the page. So case 1 on page 32 has a rotation of 1080, right? 1080 rotations. If I want to find a value to assign to cosine of 1080 and sine of 1080, how do I do that? What is the cosine of 1080 degrees? Say that again? Cosine of 1080 degrees. Do what? Don't use calculators, people.
That was cool.
How do we find the cosine of that angle? Yeah. First question is it on Earth? And that's exactly what you're going for, right? If it is not, let's get it to Earth. Okay? So first thing is now on Earth. So then we take out 360, take out 360, take out 360. How many 360s can we take out of here?
3, 2.
Well, let's do that.
3.
So
Take out 3. Yeah, take out 3. Yeah.
what do I get here?
That's 720.
All right. Still not on Earth, right? All right.
Exactly.
You get 360.
But we said to be on Earth, you got to be between 0 to 360. You can't be 360, right? Because 360, by the way, when we drew the quadrants, we had a 0 here, come out what?
360.
Come out 360. Because it says 0 and 360 were the same thing, right?
Wow.
So if I take another 360 from here,
0.
I get 0. So that means the equivalent of this thing is 0 degrees. Okay? So 0 degrees is what this gas representing to on Earth. Is 0 degree any quadrant?
No quadrant. It's on the line.
Yeah, it's on the axis, right? It's 90 in a quadrant. It's the boundary. But we get values for those. What is the cosine of 0 degree? 1. Because we had that. Sine is the same thing here. What is the sine at 0 degrees?
0.
You see that? Because all we care about is the leftover. Technically, I could write this thing. I could write cosine of 1080 to be, what's the thing? The cosine of 3 times 360 plus 0 degrees, right? This is gone, right? Remember that whole teacher's thing or co-worker thing, making money and dividing out even number of 360s until whatever's left over is what they care about. So we're just going to consider that. So 1080 is 3 times 360 plus 0. Therefore, to find the cosine of 1080, I just need to consider my leftover. My leftover is 0. That's what I'm concerned about. Because this is just purely now zeros. Okay? So I'm concerned about that. That's what we've been doing all along. We find out, is it on Earth? No. What quadrant would that be in? And then we peel the way to find out what will be the reference angle, right? Exactly what we've been doing. Throwing out 360s. We're good? Let me extend that to the next problem. The next problem says, what if we rotated 24,000 degrees? 24,000 degrees. What would be the sine and cosine? Here's the thing, the book has a mistake. Well, they just got a little bit of an error in there because they're telling you that when you rotate 24,000 degrees, there's 400 rotations. It's not. Because 400 times 360 is not 24,000. All right, somebody didn't check the math on that. But let's look at 24,000. So they want us to consider the cosine of 24,000 degrees. So we got to go through all of the steps again. Is it on Earth? If not, let's bring it down to Earth. Now that we got it on Earth, what quadrant would that be in? What does the sine of the cosine and sine values look like in that quadrant? What would be the reference angle? Now what is the exact value? We good? All right. So then let's answer those questions about 24,000. So, is it on Earth?
No.
Okay. Why?
Because
It's bigger than 360 degrees, right? So now, how many rotations can we take out of the Earth? Those of you using your external brains, the calculator, the way you find that out is to divide that thing by 360. It'll give you like 66 point something. So
666 and 6.
you sure 666?
Wait,
It's 24,000. Oh, I put 24,000.
Yeah.
24,000. 24,000. It's gonna be 66.6667.
Do 66 times 360.
23,760.
Do plus 60.
23,800.
Oh, it's not 24,000? Let me show you something. Is that 120? All right, then try 120. Oh, 240 is the number.
Dang.
66 rotations. 66 complete rotations. If I take that out, I get left with 240 degrees. Now, I'm only concerned with my leftover. I am not concerned about these complete rotations. Here is what I care about. Now, is that on Earth?
Yes.
Yes. Now we're going to ask ourselves, what quadrant would that be in?
2, 3.
Quadrant 3. And in quadrant 3, the sign is?
Negative.
The cosine is negative. What would be the reference angle here?
60.
How?
Because that's the equivalence.
How did you get it?
I subtracted 180.
All right. So the reference angle is 60 degrees. Now, everybody go to the book of Numbers, page 26. Go to quadrant 1. Find 60 degrees.
1/2 is the cosine.
Because it's closer to 90 degrees, so the sign will be bigger. So cosine is a half, but because it's in quadrant 3, it's a negative half. Sine is the square root of 3 over 2, but because we're in quadrant 3, there's also a negative square root of 3 over 2. You see that? We're good? Because you see what I'm doing every time is I'm taking out 360s. And I'm not concerned about what's left over. I'm not concerned about the leftover at this point. Right? So you know for a fact this is not Applebee's. Because you never want to be concerned about the leftovers. Because the food you eat is already jacked up. Yeah, concerned about the leftover. Leftover is going to be worse. You know, that bougie ghetto place. Don't know where they want to be. So, we're good?
No.
All right. So then here is going to be your, why do you keep pinching the page, man? You should hear right now. Even though I have mine, I left it over there. I could go for it, but I'm just going to annoy you right now. Okay? So now, state a generalization of the result. Now we got to generalize. Are we listening? We just see patterns. I show you a pattern here where you told me 1080 was 360 degrees, and we want to concern ourselves with the leftover. Okay? And then we came here to 24,000. We took 66 rotations, and we want to concern ourselves with 240. Okay? So think about those. Now, what do we say in general terms of the cosine of an angle, theta, if theta is n times 360 degrees? By the way, can I add something here? And that doesn't change the whole thing. What can I add here? Right? So, if it is just the whole thing, then there's a 0 here, right?
Yeah.
If there's nothing left over. So, what would be the cosine of that angle? I don't care what n is. N can be 3. We end up we're just dealing with 0 degrees, right? N can be 4, n can be 5, n can be 66. We just end up dealing with what's left over. Right? So what would be left over here? 0. What is the cosine of 0 in that case? And what would be the sine value?
Bless you, sir.
So all this is saying is that in general terms, after seeing a pattern where I get a number, that number is not on Earth, I have to bring it down to Earth, right? Now that you're on Earth, you know, like, so you take away rotations. We take away rotations until we get to a point where we have it between 0 and 360. And that would be what left over. So we just care about the leftover. Here, if it's just a complete rotation, then there's nothing left over. Then we end up back at 0. But we know 0 is not in a quadrant, right? Now that it's 180, now that it's 90, now it's 270. So we have any one of those things, we just on the boundary. But we know the values of the sine and cosine on those boundaries because we talked about them, right? So here is your work, case 2 and case 3. That's your work. So then tomorrow, when you get here, it's just stump the chump. But then we would have won championship, We're good? Do your work. We have an assessment on Hump Day, don't forget. Yes.
Hump day.
Oh, we could do it today.
No.
Yes. I thought we should do it today.
You already gave us.
LOG, Black Power, out!